Some of the common mechanical properties, or we can say mostly preferred, are we have stiffness, elasticity, next we have plasticity, ductility, brittleness, malleability, toughness, and hardness. Now these are the mechanical properties which we have, and see, when we are studying machine design or design of machine elements, or previously the subject was called as strength of materials, in that subject also we need to learn some basic mechanical properties so that we can understand the behavior of some materials. So here, as I have mentioned, we would be dealing with these properties in detail, and we need to have the deep knowledge of them so that we can understand the behavior of some materials. Now let us get started with the first property, that is called as stiffness. Now stiffness is the ability of materials to resist deformations under the action of loads. So this is stiffness, that it will be the ability of any given material to resist deformation, that is, a material should not change its shape when the load is applied, and when we go on increasing the value of load, then the deformation should be very small. It should not increase with the increase in load. Like for example, if I can say that if the load is 10 Newton, then the deflection is around 1 mm. If it is 20 Newton, then the deflection becomes 10 mm. So it should not be like this. The deformation should be slow. That is the meaning of stiffness. You go on increasing the load value, but the deflection is less. So here I have written about stiffness, and next its unit. Its unit is Newton per mm or kilonewton per mm. It is load to produce per unit deflection. That is, in order to produce a deflection of 1 mm, how much load should be applied? That is in terms of Newton. Or if it is in terms of kilonewton, then again, to produce a deflection of 1 mm, how much load in kilonewton should be applied? So that is the meaning of stiffness, and it is mostly considered in the design of springs. So a very important property, that while we are designing the springs, we would be considering the property of stiffness. And here I can say that stiffness is given by the formula. Here stiffness, I'll denote it by K, and that is equal to load, which is W upon deflection. Deflection is delta. So here is the formula to calculate stiffness. Now after stiffness, the next property which we have, it is called as elasticity. I'll define elasticity here. Elasticity, it is a property, it's a property by which a material changes its shape when load is applied and will regain its original shape when load is removed. So this is the definition of elasticity. It means when we apply load, like for example, here I have this pen. If I am applying a load over this, if I am pulling this pen, then its shape will change, and the moment I remove the load, it will come back to its original shape. That is the meaning of elasticity. Elasticity is measured by a term called as Young's modulus or modulus of elasticity, and its unit will be given by, its unit is Newton per mm square or kilonewton per mm square. So this was regarding elasticity. Young's modulus decides how much elastic a material is. For example, if Young's modulus is very high, it means the material is very elastic. If Young's modulus value is less, it means that material will behave in a less elastic manner. After this definition, we have the next property, which is called as plasticity. Now plasticity, it is the property by which a material is not able to regain its original shape when the load is removed. It means here in case of plasticity, the material will not gain, it is not able to regain its original shape. Like for example, I have this pen. If I am applying a load and pulling this pen, then its shape will change, and the moment I remove the load, it will not regain its original shape. Means when the load was applied, the shape has changed. That change in shape will remain permanently. So we have understood that plasticity is nothing but it is a permanent deformation, as the material is unable to regain its original shape, so it comes under the category of permanent deformation. Next, materials used in machines are never allowed behave in a plastic manner. See, this is a very important consideration. Like whatever materials we are using for machine design, that materials they should not operate in a region where the deformation would be plastic. That is, they are not allowed to behave in a plastic manner. It means whatever machines we are seeing, they are designed on the concept of elasticity. That is, they should regain their original shape when the load is removed. They should not behave in a plastic manner. So next, after this, the next property which I have here, mechanical property, it is called as ductility. Now, ductility, it is a property by which materials can be drawn into wires. A very important property, that if a material is having ductility, it means it can be drawn into wires. Now whatever wires we are seeing, like in case of electrical connections, those wires, the material with the help of which they are made, that material, it is called as a ductile material. So here I can say that ductile materials have the ability to flow. To flow means when the load is applied, the material will elongate, it will change its shape. Example, copper wires used in electric cables. The copper wires which we are using in case of electrical connections, they are all ductile materials because we can convert them into wires and they have the ability to flow. Like for example, this pen, if it is made up of ductile material, when I would be applying the load here, this pen will change its shape, and the more amount of tension I apply, I pull this material, it will get elongated and converted into wires. So again, ductility is also a very important mechanical properties. Apart from copper wires, we can say that aluminium, which is a soft material, is also a ductile material. Aluminium, since it is soft, it can also be considered as a ductile material, and we can use aluminium to convert them into wires. So this was one of the important mechanical properties. Now after ductility, we have brittleness. Now brittleness, see, it is the ability of a material by which it can break when it falls. So here it is the ability of a material by which it can break or develop cracks when loaded. So brittle materials are those in which when we are applying the load, either they can break suddenly or cracks would be developing in that material. I can give the example like wood is a brittle material. Next, we have concrete. It is also a brittle material. We, if we are having concrete and we apply tensile force, if we are trying to pull concrete, then it will break suddenly. Similarly, if there is wood, when we are pulling that log of wood, it can break suddenly on the application of load. So that is nothing but brittle material. And I can even say that cast iron, since it contains more amount of carbon, it behaves as an brittle material, because the more amount of carbon we add to metals, the more brittle they become. And when they become brittle, on the application of slight load, they can break suddenly, that is without giving any prior warning. I can write here that brittle materials can break without any prior warning, or they can develop cracks. So two things are possible: either the brittle materials, they can break, or they can develop cracks when the load is applied. So this was regarding brittleness. The next property is malleability. Again, like ductility, malleability is also the property which is desired in mechanical materials so that we can convert them into any shape. So here it is the property by which materials are able to be beaten or converted into thin sheets. So here I have written about malleability, that it is the property by which the materials are able to be beaten or converted into thin sheets. See, whatever sheets of metal which we are seeing, that metal, it has the property of malleability. That is why it is converted into sheets. Like I have given you the example of ductility. In ductility, the materials were having the property by which they can be converted into thin wires. In case of malleability, the materials, they have the property that they can be converted into thin sheets of metal, which we can use in some of the applications. So here I can say that materials which are elastic are better in malleability. That is, the materials which are more elastic, they are considered to be more malleable. So materials which are elastic are better in malleability. Next, steel, copper, aluminium, brass, bronze, etc. And I can even say that etc. Yes, even zinc is a malleable material. So here are malleable materials, and the thin sheets which we get from malleability, they can use for number of application. Like they can be used to produce some components out of sheet metal. That sheets, they can be used for roofing, for the ceiling purpose. and they can even be used for waterproofing. So some of the applications we have seen for malleability, and we have understood the definition part also. The next definition is toughness. Now toughness, I'll write the definition here. It is the property by which a material is able to resist shocks or impact loading. It means that toughness is the property by which a material is able to resist shocks or impact loading. Impact loading means impact loading refers to load falling from a height. Like if I can give the example by drawing the diagram. Here we have a load, and this is a bar, or we can say rod. Over that we have a collar. Now here I have height h through which the load is falling onto this collar. So now toughness means the ability of this collar to resist this load. Like for example, if this load is falling through this height h, then this collar should not deform much. By toughness we mean that on the application of this load, this collar should be able to resist this load. It should not go, or it should not deflect suddenly. The deflection should be minimum. If I can draw the diagram, that after deflection it will look something like this. So this much is the amount of deflection, which is delta L. So a material which is able to resist impact load means if a load is falling from a height, then that is called as toughness. And this property is very useful in the design of springs. Like previously we have seen the property which was we have seen, that was stiffness. So stiffness is required in the design of spring. At the same time, toughness is also considered while the design of springs. So I hope toughness is understood. Next we have the property which is called as hardness. Hardness is the opposite of toughness. Here I'll mention it is the property of a material by which it can resist scratches, marks, or wear and tear. So this is regarding hardness, that it is the property by which material is able to resist scratches, marks, or wear and tear. See, we decide the hardness depending on the ability of the material. Hardness is independent. I'll mention here, hardness is independent of the weight of a material. So we cannot say that if a certain material is heavy, it means it will be hard. If a material is light, then the hardness will be less. We cannot say this because hardness is independent of the weight of the material. And like for example, here I have this two different color pen. If I want to decide their hardness, then I would be scratching, I would be marking on each of the pen. And if I am able to mark very easily, or I can able to scratch, for example this red pen, if I am able to scratch this easily, it means it is less hard. Or if this blue pen, if scratching the blue pen is difficult, it means it is more hard. So hardness is regarding the scratches or wear and tear which is produced on the surface. This property is mostly preferred while designing components which slide over one another. So when we have two components and out of that one is sliding over the other, then the surface contact is more and we require hard materials, because if the material is soft and then there is sliding taking place, then there will be more wear and tear. So in case of hardness, we should be aware that the material is hard. It means it should be able to resist scratches and wear and tear. Next, after hardness, I can write one more point here in case of hardness, that brittle materials are more hard. This is a very important point here which I have mentioned, that brittle materials, they are more hard. It means brittle materials are able to resist scratches more. Like for example cast iron, it is a material which has high amount of hardness because it is brittle also. And even we can give the example of concrete. Concrete is a hard material. We are unable to scratch it. Even glass is an example of a hard material. Like we can say that glass is one of the hardest materials which is available. Even diamond is an example of a hard material. It is difficult to scratch diamond, difficult to scratch glass. Now once we have seen these mechanical properties, like we have seen what is stiffness, elasticity, plasticity, ductility, brittleness, malleability, toughness and hardness, here I'll mention two more properties. One which is called as creep, and next the other which is called as fatigue. I'll start with creep first. Now, creep, it is the ability of materials to resist high or extremely high temperatures. So as from the definition, I think it is very much clear that any material which is able to resist high amount of temperature, that material we will say that it is creep resistant. And if the material changes its shape when the temperature is high, then it would be called as the material is not able to resist the high temperature, then it would be less in creep. So here I can write down, because of creep, high amount of temperature stresses are developed. A very classic example, like because of creep, high amount of temperature stresses. Creep results in the temperature stresses, and as we know, what is the meaning of temperature stresses? See here, when we have a metal, when we are heating that metal, we know it will expand. Because of that expansion, there is some stress which is stored in the material, and that stress would be called as temperature stress. So creep is the property. I'll write down examples where we require creep resistant materials, like IC engines, that is internal combustion engines, next boilers, steam turbines, and furnaces require creep resistant materials. Means materials, see, as we can just look at the examples like IC engine, boilers, steam turbines and furnaces. In all of these we have very high temperatures. We can say from high to extremely high temperatures. So the materials which we should use in these machines, they should be creep resistant. They should not change their shape when the temperature is high. So this was regarding creep, and last we can see the next property, which is called as fatigue. See, by fatigue I can give you the example, like for example I have this pen which is red in color. Now if I am twisting this pen from one side and reverse twisting it, that is I am applying two opposite torques, and then I am changing my direction. So suppose if this material is very thin, then what will happen? Because of this continuous twisting, it will break. So here in fatigue failure, I can say that in case of fatigue, it is the property of a material to resist repeatable and fluctuating loads. It means if we have a machine or an element on which the load is repeatable, that is it is repeated in a cycle, and also it is fluctuating, the load is constantly changing from minimum value to maximum value, then what happens? The material would be fatigued and it will break. So here I can say that IC engines, that is internal combustion engines, are constantly under fatigue, because in internal combustion engines the piston is continuously moving. Temperature at first, during the suction stroke the temperature is less, during compression it increases, during the power stroke the temperature is highest, and during the exhaust the temperature again decreases. So when it is subjected to continuous variation in load and temperature, that results in fatigue, and because of that the failure which takes place, it is called as fatigue failure. And this, the common example which I can give of fatigue failure is, as I have demonstrated, suppose I have a very thin material or a very thin rod, and if I want to break that, then the simplest method is to break it by twisting and untwisting, continuously applying the load in the opposite direction, and because of that fatigue the material will break. So that is regarding the fatigue failure. So in this video we have seen all mechanical properties in detail.